Hello everyone. In this lecture, we shall learn about inverse of matrices. Okay, so what is the inverse of a matrix? The same way you have numbers, if you have 8 and you take the reciprocal 1 over 8, that is somewhat the inverse. And if you have 1 over 8, 8 is somewhat the inverse. And the reason is when you multiply 8 times 1 over 8, you get a number 1 that we called identity number for multiplication, Danny and Jarankilden. And if you multiply 1 over 8 by 8, again you get 1. So again this is identity. So 8 is the inverse of 1 over 8, 1 over 8 is the inverse of 8. Now here in numbers we call reciprocal. Now the same thing in matrices. If you have a matrix, the inverse of a matrix A, we write A inverse. And now we call inverse. And the inverse of A inverse is A. The reason for this, if you take A and A inverse, you multiply them. So A is the inverse of A inverse and A inverse is the inverse of A. In both cases, you should get an identity matrix. Now, one is the identity number for multiplication in real numbers, and identity is the identity matrix for matrices. And you know that identity matrix is what? Is a matrix you have 1 in the diagonal and the rest of the numbers is 0. So you'll get this matrix for inverse. And for inverse of matrices, we write always A inverse and we don't write 1 over A. We don't write this. We never write this. And the reason is commonly known as we don't divide by matrix. We don't have division in matrices. We have addition, we have subtraction, we have scalar multiplication, we have matrix multiplication, and we have matrix inverse. We don't have division in matrices. Okay, so what is the inverse of a matrix? Assume you have an n by n matrix A. Now the inverse is a matrix A inverse. That's how we write it, and we read it as the inverse of A, such that if you multiply A with A inverse, or you multiply A inverse with A, in either multiplication you should get identity matrix. Okay, all should be the same thing. Then A inverse will be the actual inverse of the matrix A. Now, if a matrix has an inverse, A inverse, if you have a matrix, you can find the inverse, then we call this matrix is invertible. يعني هالقراوي here. Or we can call non-singular. Singular نية. تلقى singular ب يعني inverse معنية. Okay, so if a matrix we can find the inverse, then we call the matrix what? We call it invertible or non-singular. You can use any of them. Or if a matrix A doesn't have inverse, if a matrix doesn't have inverse, you have a matrix, you cannot find the inverse, then we will call this matrix not invertible, or we call it singular. From these two notes, what you can say is not every matrix is invertible. matrix inverse هبت. But not every matrix is invertible, or not every matrix is non-singular. We have matrices that are singular, we have matrices that are non-singular. That is, we have matrices that are invertible, or we have matrices that are not invertible. Now, inverse of a matrix is unique. That means for any matrix, if you take it, a given matrix, the inverse, if I find it or you find it or someone in Africa or someone in Europe finds it, it will be the same thing. It is unique. There's only one inverse. And the way you find it is we will follow this formula. Okay. So as you see in this formula, what do you have? The inverse of A is defined as 1 over determinant of A. So you know the determinant of A is only a single number. So you take 1 over that number times the adjugate of A. The adjugate of A is another matrix that we will learn how to find it as we go forward in the case of find the inverse of 2 by 2 or 3 by 3 matrices. We will learn this one. You multiply these two, 1 over A is a scalar times the adjugate, and that should give you the inverse. But now we have a problem. The thing is, what if this determinant here is 0? In that case, if it is 0, we will have 1 over 0. That means it's undefined. So a matrix, we will have this result is a matrix A is invertible. Matrix inverse if and only if Boomer J, the determinant is not 0. Because you see that if determinant is 0, then you will have 0 on the denominator, and that's undefined. So the only way you can find inverse is only if the determinant is not 0. It should not be 0. In other words, we can say a matrix is non-invertible, inverse linear matrix, if and only if the determinant is 0. If you have a matrix, you find the determinant, it is 0, then don't go any step. Just say that the matrix is not invertible. And the reason is because of the inverse formula, you'll have 0 on the denominator of the formula, and that's undefined. Okay? In the next lecture, we will learn how to find the inverse of a 2 by 2 matrix